Everything's good. Alright, let's get started, guys. So, last time we talked about compound inequality and linear equality. Today we're going to jump to another concept, but before I start with the definition, I want to ask, any of you take 1 hour to get here? Half an hour? 20 minutes? Oh my god, 20 minutes to get here. Yeah, to get to this campus. 20 minutes?
It takes like 5 minutes.
5 minutes? Jesus Christ, I wish I could. But anyway, you see that there's so many factors that determine if you can come early or you can come late to class. Depends on weather, depends on traffic, depends on how fast you're driving. Yeah, it depends on how fast you're driving. So you see that the faster you drive, probably the earlier you can come to class. So those two quantities, you see, those two quantities kind of related to each other somewhere somehow. Or I can give you another example of something. The more time you spend on learning, the better grade you have at the end of the semester. So the grade and the amount of time you spend on learning is also related to each other some way somehow, right? Or the amount of gas you have in your car and the total distance you travel. The more gas you have, more miles you travel. So those two quantities is related to each other. In mathematics, those relations we call function. So let's start with our section 3.1. 3.1 and 3.2. We want to discuss more about function. Well, first of all, what is function? So let's jump to our definition. And I just say that function is nothing but relation, right? It's a relation between two quantities. Function is relation between two quantities. Two quantities in a special way. In a special way. So we're going to talk about that special, how special it is, okay? Alright. Or is a relation between, two set of elements. The element of the first set we call the input. It's called input. Okay. And the element of the second set is called output. Okay, so output. Now let's talk about this special relation here. The input and the output is also related to each other in a special way. How special? For each input, the function assign a unique output. Let's see how we understand this. This statement is so important, so let me underline this. For each input is assigned a unique output. It means that for one input, you get one output. If you have one input and you have two output, that is not a function anymore. I mean, if you have one x value and give you two y value, that is not a function. If you have one x value, give you only one y value, yes, it is a function. Okay? And the notation for function will be f of x equal y. Okay. The x over here, we call that independent variable. Independent variable. So sometimes we call it input, right? So x is input. And the y we call that dependent variable. Okay. Now let's go back to the example I just say at the beginning of our section today. I say the amount of miles, the number of miles you travel, it depends on the amount of gas you have in your car. So you see that the amount of gas is actually the independent variable. The number of miles you travel, it depends on the amount of gas you have in your car. So the number of miles will be dependent variable. Okay, because it depends on the amount of gas. Or I can say the grade you have at the end of the semester depends on the amount of time you spend on learning. So the grade you receive at the end of the semester is just dependent variable. Okay? So the dependent variable over here we call the output. Okay. Alright, so for example, I have, let me give you a very simple function. What if I have a function like this? F of x equal to 2x plus 1. This is called a linear function. Linear function. Okay, it's called linear function. There's so many type of function. Quadratic function, absolute function, so many of them. Polynomial function, cubic function, more and more. There's so many of them. Or I can have something like this. Example 2. G of x. I can use g of x2 equal to square root of x. So this is called square root function. Square root function. I'm so sorry that my handwriting sucks. Okay, so be patient with that.
What does the first one say? Like the f of x equals 2x plus 1. What's in parentheses?
Yeah, linear function. This is linear function. And if the function contains absolute, then we call absolute function. Okay, and if the cube root, then we call cube root function. Okay, even the square root, if you see something with x squared, then we call it square root function. So in this course, we don't have to go through one by one function. Okay, we just kind of we go through kind of the overview of what the function is only. Okay, and there are 3 ways to represent function. So on the second part, I want to talk about function representation.
The red is really hard to read from a distance.
Function representation. Yeah, I know, my handwriting is not good.
Your handwriting is legible, it's just the color.
That's just the color?
Yeah.
Yeah, but my handwriting is not good anyway, I admit it. That's what my sister keeps saying, that your handwriting sucks because I couldn't see it. I couldn't fix it. It's too late for fixing that. All right, the first way of represent function we can use is we use table of value. What if I have something like this? Let's see. It could be vertical table or horizontal table. All right. So I'm gonna have the horizontal one first. So example number 1.
Is that a Y? What is that right by it?
Where?
Right where you wrote table,
Where you wrote
under function.
Right here?
No, down.
Down
Yeah,
here?
right next to the table.
Right next to this?
Yeah.
This is number 1.
Oh.
Jesus. Oh,
It was just
number
weird.
1. It's been part 1. Because I just say that there are 3 ways to represent function. The first one is we use table. Okay. It's not good. I knocked my hand.
I'm sorry.
That's okay. I feel bad too. Alright, so on this one I have horizontal table, and over here I have date of October, OCT October, and over here I have temperature, TEMP. Okay, and I have the data like this. And I think this is just random data collected from the textbook. I don't think it represents any real data in real life. So 22, this is 23, so it is 23rd, 24th. And on the 19th, the temperature of October is 52 degrees. This is 65 degrees. This is 69, 72, 67, 58. So first of all, we have 2 quantities over here, right? On the top and the bottom one. And we have to figure out which one is dependent and which one independent. Okay. So the temperature of October depends on the date. So I know right away over here is dependent variable, which is the output. Over here is independent. It's the input. The question is, my table here represents function or not? How do I check that the table here represents function? Alright, so let's go back to the definition. The definition says what? For each input, a function assign a unique output. Alright, so let's check all the input. Okay, the input, and this is the output, is the dependent, the temperature. Let's say for each input, so this is 19, assign 52, 20, 65, this 69, this 72, 23 assign 67, 24 assign 58. So look like this is satisfying this condition. Look like it satisfies this condition, the statement here. So I know that this is function. Now I'm going to give you another table when it does not satisfy the condition. Example 2. Usually, all the independent variable, they write it on the top, and dependent variable is at the bottom. So in this case, independent variable is also on the top. It's the percent weight in pounds. Okay, percent weight in pounds. And over here is percent height in inches. Okay, and have a data like this. If he weighs 125 pounds, then his height is 64 inches. 200, 72, 110. Give you 60. Okay. 107. Give you 59. 200. Give you 68. 132. Give you 66. Alright. So I have a table like that. And I want to check if this table represents function or not.
It doesn't.
Okay. Let's go back to this definition one more time. Okay, you see that over here, for each input, it's assigned a unique output. Right? But look at this. 200 is the input. It assigns 72. But 200 also assigns 68. So it gives you two different outputs. It contradicts to the statement here. It contradicts to the statement here. If it contradicts to the statement right here, we know that this is not function. Because one input gives you two outputs. So I'm going to write over here. Input 200 give you two output 72 and 68. So that's the reason why it does not represent function. Okay. Another way to another method used to represent function is we use a set definition. So on the second part, set. What is set? I mean, say a set of all the even number. So that set will be included the 2, 4, 6, 8, 9, 10, 8, 10, 12, 14. Or I can say the set of all the odd number like 1, 3, 5, 7, 9, 11. So that is set. Or I can create a set of the furniture. So at the element of that set we'll have the desk, the table, the chair, all the furniture item. Okay. So over here I create a set of all the points. Okay. So I have 5 points. The first point, the coordinate is 3, 1. Second point, 2, 5. Then -4, 2. -1, 0. And 3, -4. Let's see that if this set represents function or not. Okay. So we have 5 points here, and each point has the x component and y components. So the x component is 3, 2, -4, -1, 3. Y component is 1, 5, 2, 0, -4. And we gotta check like if this satisfies the function or not. It satisfies this statement or not. All right, let's see. So over here I have 3, give you a unit 1. look pretty good, right? 2 give you 5. Negative 4 give you 2. Negative 1 give you 0. This looks pretty good so far. However, over here, 3 also give you negative 4. So 3 give you 1, and 3 also give you negative 4. So it contradicts to the statement right here. Because one input 3 give you 2 different outputs. So this is not a function. This, because of this, and this. So this is not a function. Okay, because input 3 gives 2 output, 1 negative 4. So it's not a function. How about this one? You tell me if this function or not, okay? Again, I'm going to have a set of 1. I have negative 1, 4, 2, 3, 3, 4, negative 4, 5. Oh, I forgot it. Oh. Yeah, this is negative 1, 4, 2, 3, 3, 4, and negative 4, 5. Do you think this represents function? Is it contradict to the statement we have in the definition? So what do you think?
It's a function.
It is a function? Yeah, it is. It is a function. Even though that over here we have the same output, but that's fine. We have the same output, but that's fine. Because over here negative 1 assign 4, and this is 3 assign 4, it's still good. Okay, it's still good. So this is, yes, this is function. Okay. So in my MATLAB, I'm sure that in homework, they're going to give you the set of one like this, and they're going to ask you, okay, this is function or not. So make sure that you look at it and you see that it contradicts to the definition we have or not. All right. And another method used to represent function is we use diagram. And the diagrams look like this. So I have a 2 set, it's like 2x. And over here is the input set. And over here is output. And on this input set, I have 3 elements. So 1, 3, and 5. So we have 3 elements, 1, 3, 5. And on the output set, I have only 2 elements, 2 and 4. Okay. Okay. Now, I want element number 1 be assigned to element 2. Element 3 also assigned to element 2. And over here, 5 assigned to 4. Okay. Question is, does that represent function?
Yes. Yes.
Who say yes? Okay. How about the other? The other say no?
It's not a unique.
1 assigned 2, 3 assigned 2, 5 assigned 4.
You just can't have two inputs, right?
Wait, no, you can't have two same inputs that have the same output, right?
You're not allowed to have one input and 2 output.
So that would be not a function, right?
That would be a function.
Yeah, look, now, if you have one input and 2 different output, that is not function. Other than that, the rest will be function.
So this is not a function?
So this is not a function.
No, it isn't.
This is satisfied that? Alright, it's one input give you 2 different output.
No, it's vice versa. It's two inputs giving the same output.
One input give you 2 different output, that is not a function. Do you think this is one input give you 2 different output?
Wait,
No.
oh no, it doesn't give a different, okay.
Yeah, well, this is we have 2 output give you 2 input give you 1 output. But what I said is 1 input give you 2 output. So this is still a function. It's still a function.
Okay, I understand.
Okay, this is still a
I
function.
understand it.
Alright, so this is function.
Yeah. I was thinking the 3 and another 3.
Well, this is 5 assigned to 4. That's good already. That's unique. Okay. Alright, how about this one? How about this one? Okay. Okay, have this. Have this. Input here. Output here. I have a few elements here. And over here I also have few elements. So this is 1, 2, 5, 7, and over here is heart, diamond, club,
Spades.
spade. There you go. I have 4 elements right there. Okay. And now I'm gonna start assign it. Okay.
Wait,
Now.
that's 1, 2, 5, 7?
Yeah.
Now let's use different color here. What's that? 1, 2, 5, 7. Yes.
Oh gosh.
Alright. Now I'm gonna draw like this. This is go over here. 2 go also to heart. 5 go into diamond. Okay. 5 also go into spade. Okay. 5 go into club. And 2 go into 8.
Wait,
Alright.
where does 7 go to again?
7 go to 8. 7 go to 8. Oh, I forgot the arrow. Alright, let's see. What do you think? Let's let everybody go ahead and write them down first and start thinking. Okay. Alright, he said that this is not functional already. So what do you guys think?
Very her head,
This feels like one of those games where you have to connect the dots.
I just remembered the same. I
This is not, I don't think it's a function.
Okay, so it's not a function? It's not a function? It's not a function?
Oh, because no, 2 and
Okay, why do you think it's not a function? Please give me the explanation here.
Because two and 2 have 2 different outputs.
Ah.
2 and 5 have two.
Yeah.
Ah. Good. So far so good. All right. Now on the next example, what if the function is not given in the table or it's not given as the as a diagram. It's not even it's not given as the set. Whatever they give you like this. F of x equal to x plus 1. And I want to find the domain of this. Find domain. So how are we going to do this? So in order to find domain of this function, we must be able to graph it on the coordinate system. Okay? And this is linear function. We're going to talk about linear function specifically maybe today's Tuesday, maybe on Thursday. Okay? But right now, because I don't want to go to this linear function too much in detail, so we're going to graph it by setting up the table, the value table, and we're going to connect all the points together. Okay? Because this is a line, so as long as we have 2 points, we can connect them and we can get a line easily. Okay? There's another way to graph linear function, but I'm going to talk about that on Thursday. Okay? Alright, so let's graph this. Alright, so let's make a table. Everybody know how to make a table. So over here I have x. Over here we have fx. Alright, so you can plug in any value you want. Okay, so I'm going to plug in 0. Plug 0 over here, give you 1. If you put 2, give you 3. That's good enough. You just need 2 points. Well, you can get more than 2 points if you want to. The more points you have, the accurate it is. But as long as you have 2 points, you can connect them and you can get a line. Okay. So 0, 1 is right here. 2, 3 here. 2, 1, 2, 3. There you go. You have 2 points. Now I can connect them. I can connect them in order to get the line. So it's going to be something like this. Okay. Now based on the graph, okay, we can look at the domain. We can find the domain. Because the domain is what? The domain is all the set of all the input that make the function define. It means that you look at the x-axis. Okay, you look at the x-axis, and you pick any point here on the green line right here, and you see that you can draw the vertical line perpendicularly to the x-axis or not. So if you have a point here, so look like here you go, you got a value of x, right? If you have a point here, you also have a value of x. You have a point here, you also have a value of x here. So no matter what points you have on the green line, you can have the x value correspondingly, right? So it means what? It means all the domain, all the value on the x-axis here will be the domain. So if every value on the x-axis of here is the domain, so how am I going to write it in interval notation? Yes. So the domain will be negative infinity. How about the range? Do you think the range could be negative infinity to positive infinity too? Right? Any point on the green line, I can draw perpendicular to the y, and so on. Yes. Okay. So that is how you find the domain when it given you algebraic function. Okay. Any questions so far? Okay, very good, very good. Okay. Now on the next part, so after we know how to find the domain and range of the function already, we will be learning how to find 2 points. We call that x-intercept point and y-intercept point. What is x-intercept point and y-intercept? Which is the intersection point between the graph and the x-axis. Y-intercept point is the intersection point between the graph and the y-axis. So given any function, algebraic function, we can find x-intercept point and y-intercept point easily. So let's jump to part 4. X, Y, intercept point. And no concept over here, the X, Y intercept point here, actually we can use it to graph linear function. And we're going to learn how to do that on Thursday. Okay? So x-intercept point okay, is intersection point between a graph and x-axis. And y-intercept point is intersection point. Okay. Is intersection point, okay, between a graph and y-axis. Now I want you to look at this one right here. Look at the line right here. So right here is actually the x-intercept point, right? Because this is the green line. Oh, you guys still there? You see the green line over here, it cut the x-axis at this point right here. I call point A. And over here I call it point B. Point B is actually the y-intercept point because it's cutting the y-axis. Okay. So if you look at point A over here, what is the y component for point A? What is the y component for point A?
0.
0. What is the x component for point B?
0.
0. So it means what? It means every time you want to find x-intercept point, you replace y with 0. And if you want to find y-intercept point, you replace x with 0. Okay? So on the next example, I give you the function like this. F of x equal to let me see. Negative x squared plus 7. So this is quadratic function, okay? Because it's a square, so it's a square, so this is quadratic function. I want you to find x and y intercept point. Okay. Find x and y intercept point. Alright, let's find it. Let's find x-intercept point first, okay? X-intercept point. And I just said that for x-intercept point, we replace x with 0. We replace x with 0. Alright, so I'm going to plug them in. Okay, I'm going to plug them in. So fx equal y, that's going to be y equal. Alright, I'll put 0 in here. So it becomes negative 0 squared plus 7. Negative 0, we don't have it, so basically it's just 0. So we give you 7. And because it's the point, okay? Because it's the point, so we have to put in all the pair forms. Would be what? Would be 0, 7. Okay, so make sure that you have to put in all the pair form. Okay, if you don't, then it's not an x-intercept point. It's not an x-intercept. This one, if we don't put it in all the pair form, this is called x-intercept value. Oh, I think I do something wrong. Yeah, I think I did something wrong. So with x-intercept, we replace. I'm sorry. Oh, sorry, guys. So replace y with 0, so be like this. Now we're going to solve for this. So how I'm going to solve for this? So you're going to have x squared equals 7. Right? And you're going to take square root both sides. Right? To give you x equal plus minus square root of 7. Remember, when you take square root both sides, it will be plus minus. Now then we're going to have two x-intercept points. The first x-intercept point will be square root of 7, comma 0. And the second one will be negative square root of 7, comma 0. Okay. So remember, when you find x-intercept point, we replace y with 0, okay? Then solve for x. Okay. Now, let's find y-intercept point. Let's go over here. Y-intercept. Then we replace x with 0. Alright, so my y become y equal negative 0 squared plus 7. Okay. So y equals 7. If you stop over here, it's not a point yet. If you stop over here, we call it y-intercept value. It's not a point. Okay, so you have to put in all the pairs. So it could be 0, comma 7. Okay. Any questions so far? And it's not really hard, but you just have to memorize it. Okay, for x-intercept point, you have to replace y with 0. For y-intercept point, you replace x with 0. It's nothing hard. It's just you have a couple things you have to memorize in this section. Okay. Now you see over here that go back to this graph right here. At 2, right? At 2. The output, if the input is 2, the output is 3. You know. So what you do over here, you replace 2 over here. You put 2 into the x, right? And you calculate the output. That step is called evaluation of function. So given a function, any function, and you can evaluate that function at certain x number, certain x value easily by just go ahead and plug x into the original function. So on the second example right here, I think I might put in part 4 too. Given a function like this, given f of x equal to absolute x plus 3. This is called absolute function. I want to evaluate fx at x equal -5. Okay. All right. So let's see how we're gonna do that. All right. Just evaluation. Basically, you just go ahead and plug them in. So f at x equal -5, it means that you calculate f of -5. F of -5. -5 will be input. When you calculate f of -5, basically you calculate the output given input. Okay? So you just go ahead and plug them in. So -5 here, -5 plus 3. -5 plus 3 give you -2. And absolute of -2 give you
2. -2 and +2. Right?
just 2.
Or just 2?
Just. It's always give you positive.
Oh, right.
Yeah, remember that. Okay. And what if I want to ask you like evaluate fx at x equal 10? You just go ahead and plug in 10. Evaluate at x equal a half. You go ahead and plug a half in. Okay. And if they give you a graph, okay, if they give you the graph by your own observation, you see that okay, what if I want to evaluate at x equal 1? Then you look at the x equal 1 and you look at the output correspondingly to 1. For example, over here, what if I give you the graph like this? And I ask you to evaluate f of 2, and you look at the graph and you see f of 2 is 3. Okay, so if they give you the graph, most of the time, yeah, they must give you the output value. If they don't give you the output value, what if they just put like this, without number 3 over here, and they ask you to evaluate at x equal 2, then there's no way you can get the output. Okay? So either they must give you the graph, or they must give you the algebraic function. Okay? Any questions so far? All right. Okay, so I think that's all for section 3.1 and 3.2. I'm gonna pause over here a couple. Come on, we're still early. Come on, we're not leaving yet. Oh no. So I'm gonna put some some problem for you to practice. Maybe just a couple of them before we leave. Okay. Don't rush it. Alright, so I want you to find, alright, practicing time. Okay. I want you to find X and Y intercept point. This is very important concept of the following function. F of x equal to 2x plus 1 over x minus 5.
That's the intercept point.
Yeah, X and Y intercept point.
Okay.
Go ahead.